Hi, I am Sanjay Patel. Today we are going to discuss the concept of left and right limits of a function. Before that, let us recall the definition of limit of a function, what we understood in our previous lectures. You know the meaning of this symbol, limit x tends to a, f of x is equal to L. This we can describe mathematically using the condition which is known as epsilon delta condition, and it is given by this. We know that fx tends to L as x tends to a means for every epsilon greater than 0 there exists some delta greater than 0 such that whenever 0 less than mod of x minus a less than delta implies mod of f of x minus L is less than epsilon. The meaning of limit, as you know, roughly speaking, as the values of x approaches the number a either from the left hand side or from the right hand side, the values of the function fx, corresponding values of the function fx, goes near and near to the number L, and that can be described mathematically by this condition which we call as epsilon delta condition. You know, this is known as epsilon delta condition. Okay, so this epsilon delta condition we can also write in various forms. So I want to write down this 0 less than mod of x minus less than delta in terms of inequality. So let us remove this modulus. You know, we can write as a minus delta less than x less than a plus delta, and this 0 less than mod of x minus a means x is not equal to a. So we can include this way. So whenever this is true, implies fx minus L is less than epsilon. So the difference between the values of the function and the number L we can make as small as we want, and that nearness or the closeness is measured by the positive number epsilon. So epsilon is given by some third person. It is a very small number, positive number, and you can make the distance or the difference between the values of the function and L as small as you want, and for that you can find some interval about the point A, so that whenever you take any x in that interval, a minus delta comma a plus delta, you can have this fx minus L less than the degree of say tolerance you want. Okay, so what we want to understand more clearly or more deeply is this: if you consider say a real line, say let me consider this way. Suppose if I consider a real line, okay, and let me take an interval on this number line, say if I consider a point somewhere here, this point is not to be included because we are taking x not equal to a, and the interval I am writing here is a minus delta, and here it is a plus delta. So this distance is the radius of the neighborhood, delta. Okay, whether you measure from here or here, this distance is delta. So this condition says whenever you choose any point either from left or right in this interval, either here or here, the difference between fx and L can be made as small as you want. Now instead of taking x on both the sides, okay, and instead of taking x in the left hand side of a or on the right hand side of a, this left hand side means this side of a, some people also call it negative side or negative direction. So this is known as negative direction or negative side. and this side we call as a positive side, okay, or the right hand side, positive side or the right hand side, and this is called negative side or the left hand side. So when you take any x here only in the left hand side of the point A, so if I choose any x only in the left hand side anywhere here, and still if the difference between fx and L can be made less than epsilon for any x between these two, then we say that as x goes near and near to the point A from the left hand side, the function fx approaches the number L, and that situation or that limit, that approach of the function is called left limit or left hand limit of the function at the point A. The same way, or let me explain more precisely by using a symbol. So that situation will denote whenever we choose any x only here, say if I choose a minus delta less than x less than a, any x between a minus delta and a, and still if I get this mod of fx minus L less than epsilon, okay, see other things as it is. So given any epsilon or any value of closeness, it's a positive number epsilon, if we can find some delta so that for every x between a minus delta and a, if mod of fx minus L less than epsilon, then we say that as x goes near to a from the left hand side, and that is denoted by putting minus sign over here, and it is called left hand limit. As x tends to a minus, the function fx goes to the value L, okay, and more precisely or more mathematically we can write it as limit x tends to a minus f of x is equal to L, or we can also write using the symbol f of a minus is equal to L. Remember, f of a minus does not mean the value of the function at minus a, it means it is the left hand limit of the function at the point A. Thus minus sign indicate it's a negative side or left hand side. The same way now you will understand immediately how one can define the right hand limit. In this case this number L is called right hand limit. Same way, if you have any value here of x in the right hand side of A, by taking any x, if you get again the same situation true, that is whenever a less than x less than a plus delta is given, again if we have only this fx minus L less than epsilon, then we say that as x tends to a from the right hand side, that is plus a plus, the function fx goes to L or it approaches to L. In this case L is called the right hand limit of the function fx at the point A, and it is again denoted by the symbol limit x tends to a plus f of x is equal to L. Again remember that the plus sign indicates only the positive side or the right hand side. Another notation is f of a plus is equal to L. So let me write down this discussion more precisely as a definition of left and right limit. So definition of left hand limit will be like this. Let f from x to r, we know, we have already discussed that we are going to take a functions of this form where x is any subset of r, be a function and the set x, the domain x contains some deleted neighborhood, just a minute, contains some deleted neighborhood of the point of A is any real number of a point A belongs to R. these are the two things given. And we define the first definition of left hand limit like this. The definition of left limit or left hand limit. Okay. So it goes like this. If there exists a number, a real number, if there exists a real number L with the following property, and what is that property? It is our epsilon delta condition. It says for every epsilon greater than 0, there exists some delta such that whenever the a minus delta less than x less than a implies mod of f of x minus L is less than epsilon. If this condition is satisfied, then we say that as x tends to or x approaches to a from the left, the left limit of or the left hand limit of the function fx is L. So this is our left hand limit definition. So if there is a number L with this condition which satisfies this condition, for all epsilon, if we can find some delta, so that only on the left hand side of the point A, the difference between fx and L is less than epsilon. And symbolically, it is denoted by, as we have discussed earlier, it is denoted by the two symbols, limit x tends to a minus f of x is equal to L, or f of a minus, remember this new notation, f of a minus is equal to L. Same way, we can define the right hand limit like this. So next is our definition of right limit. It goes in the same way, except that change in that inequality. So I will write down the same thing. If there exists a real number L with the following property, only the change will be in this condition. As you know, you take x in the right hand side of A in the neighborhood a comma a plus delta in that open interval. So if there exists a real number, L with the following property, that for every epsilon greater than 0, we have written that same condition, for every epsilon greater than 0, let me use, there exists delta such that whenever a less than x less than a plus delta implies mod of fx minus L is less than epsilon. If this condition is satisfied, then we say that as x tends to a from the right, okay, so then we say that as x tends to a, from the right hand side, from the right, the right limit of the function fx is L. Okay, and it is denoted by the symbol limit x tends to a plus f of x is equal to L, or we may also write using this notation f of a plus is equal to L. So this is the concept of left limit and right limit of a function. Okay, one thing follows very immediately, that your function has a limit at a point, means if this condition is satisfied, in other words, if a minus delta less than x less than a plus delta implies fx minus L is less than epsilon, then it is obvious that this condition and the other condition, this a less than x less than a plus delta, both will be satisfied simultaneously, means both left and right limit definitely exist. So in other words, from this discussion, it is clear that if a function has a limit at a point, then both left and right limit exist. In fact, the converse is also true. So that I can write as a result or a theorem. Prove that limit x tends to a f of x is equal to L exists if and only if both left and right limit exist and they are also equal to L. If and only if limit x tends to a minus fx exists is equal to L, and also limit x tends to a plus f of x exists and is equal to L. So both exist. So this is a theorem. Let us prove it. Proof is very simple of one part. You must have understood by now that the first part is obvious, that is this main part. So suppose limit x tends to a f of x is equal to L exists. This is given to us, and in this case we want to prove that both left limit and right limit exist, which is very simple. So we start with an epsilon greater than 0 be given. Let epsilon greater than 0 be given, and because of this there exists some delta greater than 0 such that whenever 0 less than mod of x minus a less than delta implies mod of f of x minus L is less than epsilon. This I want to again write in a different form that you know very well. So I will be writing this way, that is a minus delta less than x less than a plus delta and x not equal to a implies mod of fx minus L is less than epsilon. Still we can write this as, that is a minus delta less than x less than a, x belongs to this interval and x is not equal to a, means either x is here or x is in the right hand side of a. So this or this implies mod of fx minus L is less than epsilon. Remember that, note that x is not equal to a. Okay, so that this last statement says whether x satisfies this condition or x satisfies this condition, mod of fx minus L is always less than epsilon. So writing these two separately, our aim is proved. So thus I can say whenever a minus delta less than x less than a, this is true, and also whenever a less than x less than a plus delta, again we have mod of fx minus L is less than epsilon. So the first condition, there are two things. This is number one and this is number two. One means the limit x tends to a minus fx is equal to L, and two means limit x tends to a plus fx is equal to L. So both left and right limit exist and they are equal to L. So one part is done. What I have proved is if limit of function x is equal to L, then both left and right limit exist and is equal to L. The converse part is some more interesting. It's not that straightforward. Let us prove the converse. What is given in the converse part is both left limit and right limit exist and is equal to a. So x tends to a minus fx is equal to L and is equal to limit x tends to a plus, that is also equal to L. This is given, both exist. What is our aim? We want to prove that limit x tends to a fx is equal to L. So we'll use the definition, that epsilon delta condition, and show that this is true. That is, for any given epsilon there is some delta such that epsilon delta condition is satisfied. So let us start with epsilon greater than 0 be given. Okay. Now because of this, as f of a minus is equal to L. What is the meaning of this? This means limit x tends to a minus fx is equal to L. There exists some delta which I would like to call, say, delta 1 greater than 0, such that whenever we have a minus delta 1 less than x less than a, implies mod of fx minus L is less than epsilon. And let me call this as result number 1. This we are writing only from the definition of left hand limit for this first step. This is given to us. Now I will be using the second part, limit x tends to a plus fx is also equal to L for the same epsilon. But remember, the delta we'll get may be different. So here again I can say as f of a plus is equal to L. F of a plus means the right hand limit of the function at the point A. As right hand limit is L, for the same epsilon there exists some positive number, say delta 2, such that whenever a less than x less than a plus delta 2 implies mod of fx minus L is less than epsilon. And let me call this as result number 2. So this 1 and 2 I am writing just from the definition of left and right limit. What I want to do is, given epsilon, I want to find only one delta which is greater than 0, such that whenever 0 less than mod of x minus less than delta implies mod of fx minus L is less than epsilon in order to prove our requirement. Okay. I want condition 1 and 2 both holds, because the condition 1 means we are taking the values of x in the left hand side of A, and condition 2 means we are taking the values of x in the right hand side of A. So to do that, let us put minimum of delta 1 and delta 2 and declare as delta. So put delta is equal to minimum of delta 1 and delta 2. Okay. So this implies delta is positive and delta is less than or equal to delta 1 and delta is less than or equal to delta 2. Okay. So if I write say if I consider this delta less than delta 1, then for this particular delta 1 I can say explain this way, as delta is less than or equal to delta 1 implies minus delta 1 is less than or equal to minus delta. If you multiply by negative 1, you will get this. Now adding a both the sides, you will get a minus delta 1 is less than or equal to a minus delta. The same way I can use this thing and write delta less than or equal to delta 2 implies a plus delta is less than or equal to a plus delta is less than or equal to a plus delta 2. So just keep in mind these two observations. Now what I want to do is this. Okay. So this suggests something like this. If I explain on a number line, say consider okay, and if I take the point A somewhere here, point A, then A minus delta 1 is less than A minus delta. Okay, A minus delta 1 is less than A minus delta. So it will be definitely on this side. So A minus delta 1 is here, A minus delta is somewhere here. Same way, A plus delta is less than A plus delta 2. And you know A minus delta is obviously less than A plus delta. So A plus delta will be somewhere here and A plus delta 2 will be somewhere here. So now it is clear, if I choose any x here in this new interval, whether on the left hand side of A or on the right hand side of A, in this interval having the radius delta, in this interval, just a minute, in this A minus delta to A plus delta, in this interval, what happens is both the condition will be true. So thus if A minus delta less than x less than A plus delta and x is not equal to A, I do not want to take this A because it is not included anywhere. So for x not equal to A, what we can write is, this implies A minus delta 1 less than A minus delta less than x. Okay, and it is means there are two possibilities, that x can be, let me write in a different way, in just a more detailed way. Say if I choose x between these two, it means either A minus delta less than x less than A is true, or A less than x less than A plus delta is true, because x is not equal to A, so I cannot include A here. And this means that A minus delta 1 less than A minus delta, as we are discussing in star, you see this, which is less than x less than A, or A less than x less than A plus delta, which is less than or equal to A plus delta 2. Here also I should write less than or equal to. So in any case, if x is satisfying this condition, from result 1 I can say mod of fx minus L is less than epsilon, and here also if x is satisfying this condition, then again from result 2 I can say mod of fx minus L is less than epsilon. let me show you what is result 1 and 2. Result 1 is this: whenever x is between a minus delta 1 and a, fx minus L is less than epsilon. And here it is a minus delta 1 less than x less than a. So fx minus L is less than epsilon by result 1. Let me write more clearly. This we are writing by 1 and this we are writing by result number 2. But in any case, we are getting the same thing. So for whatever x we choose between a minus delta to a plus delta and x not equal to a, we are getting fx minus L less than epsilon. So that proves the requirement. So therefore, whenever means what is proved is for every epsilon there is some delta greater than 0 such that a minus delta less than x less than a plus delta and x not equal to a implies mod of fx minus L is less than epsilon. And this means, it is nothing but 0 less than mod of x minus a less than delta. And thus, we can conclude that limit of fx as x tends to a is L. So hence, limit x tends to a, fx is equal to L is proved. So thus, remember, if a limit of function exists, then both left limit and right limit exist and they are equal to the value of the limit. And converse is also true. And this is very useful. The concept of left limit and right limit is very useful for discussing the continuity of a function. And just finally, we discussed in one of our lecture that the left limit and right limit of a function may or may not exist, but if a function has a special nature, okay, like if a function is strictly increasing function and defined on some interval, so something like this, if f is a strictly increasing function defined on some interval is strictly increasing function, then for any point C belongs to open interval AB, that is for any number between A and B, A less than C less than B, the left limit and right limit both exist. F of C minus and f of C plus both exist. So this gives you guarantee, the strictly increasing nature of a function gives you guarantee that left limit and right limit definitely exist. It may happen that they may or may not be equal, okay, but its existence is definitely guaranteed. So this is also a very interesting result we'll discuss in our one of the lecture. Okay, so today we have introduced the concept of left limit and right limit of function and proved the important theorem. Okay, thank you.